be using binomial theorem, alright? Or in descending powers whereby we have 512 x power 9 minus q x power 8 and so on. So making use of our binomial expansion, right? If you recall our binomial, okay, it looks something like that, and then after that with the general term and so on, right? So using our binomial for our px minus 3 to the power of n, I will find that I have px to the power of n plus n choose 1, a is px, n minus 1, okay, b is your negative 3, alright? And then after that, we don't need to continue with the expansion since it only gives us our first two expansion. Correct? So we can just end here plus dot dot dot. Right? Then we expand this one, rather we simplify our work here. So p to the power of n times x to the power of n. N choose 1 is n. P to the power of n minus 1. X to the power of n minus 1 times negative 3. Okay, we rearrange this a bit such that we can see clearly the coefficient segment and the variable segment, meaning to say we have our negative 3 placed in front. So let me just adjust it here. And I'll arrive at this. Okay, so this is where I really just apply my binomial formula. Then I can compare. Okay, I compare my coefficients, I compare the terms, alright, between what is given and what I already have. So I will see that Pn to the power, P to the power of n times x to the power of n is equals to 512 x to the power of 9. Okay, so by comparison, I will be able to see that n has to be equals to 9 and P to the power of n is equals to 512. So since I know that n is 9 already, p to the power of 9 is equals to 512. Okay, then p will have to be the 9th root of 512. You can press it into your calculator in this form, or you can do it as a power form, your rational index. 512 to the power 1 over 9. Okay, and I will be able to have this is equals to 2. Okay, so that's comparing the first term. Then when I compare the second term, I have negative 2x to the power of 8 to be equals to my negative 3 n p n minus 1 x to the power n minus 1. Okay, I already got my n and p settled. So therefore, I will have negative q equals to negative 3 n p n minus 1. Replace the n and the p accordingly. And I will be able to compute. That is will have to be 6912. Okay, sorry, negative 6912 and q is 6912. Okay. Any questions? For question 19, may I know the problem is it in part I or in part 2 or in both? Part 2? Part I, any problems? Okay, part 2 Right, then I just go into part 2 itself, but I still need some part I's answer. Okay, in part I, you should have gotten k is equals to half. Right? Then in part 2, constant term. Okay, having no constant term might actually mean that the constant term is 0. Okay, because it doesn't exist, so it has to be a value of 0. So how that can come about? Okay, it depends on the expansion itself. We notice that in this question, we are taking 1 plus x power 4 to multiply with what we have in part I. Okay, so if I want to do my rainbow method, imagine this one is expanded with a lot of things here. I want to do my rainbow. Okay, like that. Alright, so what is it that I need to multiply with 1 in order to get a constant term? And then what is it that I need to multiply with x to the power 4 in order to find a constant term? Okay, so I need to go in search of the constant term through the rainbow method, the expansion itself. So for 1 itself, I know that I need to multiply with another constant term. So from here, the expansion, I need to find x to the power of 0. Okay, something x to the power of 0 to multiply with. Then the x to the power of 4, right? Okay, I need to multiply with 1 in order to get the x to the power of 0. Wait. What is it that I need to multiply with x to the power of 4 in order to arrive at the x to the power of 0, which is our constant term? X to the power 1. Sorry? Negative 4? Do you say that? Okay, yes. So we need to multiply with negative 4. It's something that has a x power negative 4 over here. So something else. Right? So this is the idea that we need to have. Okay, so now we go in search of that. Right? We go and search out what is the x to the power 0 from this expansion and what is the x to the power negative 4 from this expansion. Okay, so in this case, in part I, you may have already found out the general term. Okay, so let me just work it out quickly for the general term here. The formula for a general term is this, right? So for the expansion, okay, I will have 8, choose R. A is x to the power 8 minus R. B is negative half over x cubed to the power of R. Right? So now I'm using the k value half already. You might already have a simplified form for part I, so dependent on yourself. Okay, this simplifies to be negative 1 over 2x cubed to the power of R. Okay, so I'll have, how I get this 8 minus R minus 3R is because 1 over x cubed to the power of R, this will become 1 over x to the power of 3R. So since it's in the denominator, it becomes minus 3R. Okay, so it simplifies to this. So we see the coefficient portion and the variable portion. Okay, so now we want the x to the power 0. If you have already simplified it in part I, you only have to substitute in the k equals to half. Okay, into your answer in part I. Right? So with this, okay, sorry, let me take a look. Okay, our x to the power is 0. Okay, so when 8 minus 4r equals to 0, I find r is equals to 2. So our term number 3 is eventually will have to be x to the power 0, and that would give us what is it? A choose 2 times 1/7. Okay, so we now know that this part here has to be a 7x to the power 0. Okay, and then our x to the power negative 4 term, that means the power 8 minus 4r has to be negative 4. So r is equals to 3. That means we're finding the fourth term. And we find that it is actually a negative 7x to the power negative 7x to the power negative 4. Okay, so what this arises in is that we get 1 times 7x to the power 0 and x to the power 4 times negative 7x to the power 0. Okay, and when that multiplies together, okay, so if I were to continue my work on this side of the whiteboard, okay, in the expansion, the constant term is 1 times 7x to the power 0 plus x to the power 4 times negative 7x to the power negative 4. That gives us 7 minus 7, and we show that it is 0. Okay, so constant term is 0 in the expansion. Right? Therefore, we can say that there is no constant term. The constant term is 0. There is no constant term. So that will be your explanation. Any questions? If not, could you submit your chapter 6.2 homework to the front and also the holiday assignment? Okay, I will not go through the holiday assignment, I will go through it after I complete. right? Is it whose one? This one? Is this yours? Morning. Okay, who hasn't given me the chapter 4 assignment? When can I have it? Anyway. Thursday, Okay, then the homework, other than we, all submitted, right? Okay, let's continue our linear law, our chapter, what's this chapter? 9, yeah. When I have homework. Sorry. Next lesson. That's next week. This week no more A-Maths, I said it right at the beginning of the lesson, you know, Joseph. So when can I meet? Sorry? Where you can meet me? Smartphone. Sorry? What do you want? Yeah, linked. One. I see the one side. By end of this week, Thursday. Can. By the way, the ESWA3, right? Okay, just to let you know, okay, since most of you are here, tomorrow I'll say it again during next lesson. We are going to not postpone, we are going to bring it forward to Wednesday, okay? Because I hear that you all got a number of humanities paper on the day, right? Am I right? I saw the booking, got history, got geography, I don't know. I don't know. Cannot postpone, okay? This day got how many paper? Tell me, never write anything yet. How many papers are there on this day? You got POA. Then what am I doing here? Or what are you doing here? And clearly over here write POA. What's there on this day? Oh, the problem is because back to back, is it? Then this one, bring forward. Is there any test over here?
I don't know.
Is there a test over here?
Yes.
There is, right? How many do you all have?
There's elective history.
There's elective history. What else is there? Anyway, this is the same for 306, the SB Beyond the Express one. Also same thing, right? Change to fifth, right? So actually same consistent one. Yeah. This one. So down here history. Down here got anything? So you all prefer 2 tests in a day?
So who would like that?
So then shift to Wednesday better, right?
No, but then we get lesson time to study.
Just one day only lah, come on.
Now
Yeah.
Friday.
No, but one day is very different.
It's not going to
Friday, Friday no math. Friday no math. Huh?
Wow.
I think I got enough E-Maths lesson with you already. Don't need to extend more. You tell me extend the A-Maths is more important. But of course I don't want to extend today's
The
lesson.
email very tough.
Like why like that? So E-Maths
Oh no.
WA3 chapter 6 and 7.
So the next week lah.
Yes. 20 marks. 45 minutes. Okay? Don't worry about the E-Maths. E-Maths I will have the time to do revision. Okay? When is A-Maths? A-Maths is week. Yeah, it's the week 10 no? Then down here Friday Friday, even week, Friday. Okay? Okay, so let's continue with our chapter 9. I hope I can squeeze out one graph today. Yes, this chapter got graphs. Let's look at this first. Okay, so far what we have done in chapter 9, just do a recap. We have learned how to change a non-linear equation into a linear form. We rely heavily on y equals to mx plus c, and then from the linear form, okay, we will be able to arrive with the gradient and the intercept value, okay, the vertical intercept value. And we can also make use of gradient and intercept and do the reverse, okay, to arrive at a non-linear equation. Okay, so that is what we have covered so far. Alright? Those who missed the previous lesson because you got oral exam, the video already uploaded. I don't know why I only got 2 views. I definitely have more than 2 students who didn't arrive. Yes.
What's the channel name?
What's the channel name? Very good, Zhen. Go and find out from your friends. Okay. You just tinyurl.com/YouTubePub. Okay, let's look at exercise 9.1, question 4C. I think I last gone through 4B already. Yes. This year already, yeah? Oh, okay, so you're one of the views, you were here, but you went out halfway, huh?
I was another.
Oh, okay. So C I do already, is it? You sure? Oh, okay. So haven't do 9.1 question 5, right? Okay, thank you. So 9.1 question 5 haven't do all? Okay, great. So, yeah, so tell me do already. Part D I want. Yeah. Done. Okay, so in this question, we want to express y in terms of x with a given diagram. Okay, and we notice that we got logarithms that we need to deal with. Okay, so this is a straight line graph. Alright, in straight line graphs, we can only determine the straight line equation. Okay, and straight line equation is y equals mx plus c. So since you're given 2 points, you can go and find out what is the gradient. Okay, so the gradient, we use the formula and we have -1. Okay? So our aim is to determine a straight line equation. Okay? So earlier on, last part of the term, we learned about big Y, big X. Okay, so I can label this big Y, big X. So I just define it here. Okay, and now I create my linear equation for this graph. Right? So our linear equation, y equals mx plus c, you can use that format to do, or else we have already learned how to use big Y minus away 1 coordinate 2 equals to gradient x minus 2. Okay, this is using our formula y minus y1 equals to m times x minus x1 to find equation. Alright, then I will get big Y equals to negative big X plus 4. So I have the linear equation now for the graph that we've given already. Our aim is to actually express small y in terms of small x, not big y's in terms of big x. Okay, so what this means is that I need to change the big y and big x. So I'm going to arrive at this. Okay, and now Okay? How can I get rid of the logarithm? If I want small y and small x only, that means I don't want to have my logarithms at all. What do you think we can do? What will you do, Reina? What will you think of doing? Change the form. Is it form? Change the form to log. Okay, how to change to log? How to change to log? 4 log length. No? Okay, you want to abandon plan? Any other plan? No? Okay, what do you think? What will you try to do? Our logarithm loss. I think I gave you all the small booklet, right? I think inside got logarithm loss, correct? Did I bring mine up? How will I make use of my logarithm loss? We have log x plus log log a plus log b equals to log ab. We have log a to power r equals to r log a. And then we have log a minus log b equals to log a over b. Generally, we have things like that. If I have my loss in such a manner, how will you try to do?
Move the log x over.
Okay, very good. We move the log x to the left, followed by,
Multiplying.
Okay.
Log xy.
great. So we get log xy equals to 4. Okay, so at least we cut down on one log already. Agree? And now that we have cut down on one log, okay, I'm essentially looking at log, okay, xy is together one now. Right? You can put the brackets, you can put it without, we will understand it, right? So, as only in this particular case we understand. If you put things like that, you never put brackets, it makes a whole lot of difference. Okay, so sometimes brackets are important, sometimes brackets are optional. Alright, so we now have this in single logarithm form already. Since you're looking at common log, meaning is to say that the base is 10, how can we entirely get rid of the logarithm? We need to change it into a certain form called what? Yes, Rina. 10 to the power of 4, then equals to xy. Okay, so we change it into an index form, right? If you remember, okay, our base number is 10. Okay, bring it, this one is always the power equals to xy. Right, that's how we do our logarithms. Okay, then 10 to the power of 4 is your 10,000. Right, equals to xy. Question wants y in terms of x, so y is equal to 10,000 divided by x. Okay, and that answers the question. Right, let's move on to look at try form. Okay, so in triform we are not given a diagram at all. Okay, it is essentially just a word illustration of a picture. Okay, we have y over x plotted against x squared. If you need to, you may draw a diagram on your own. Okay, so if you draw a diagram, we are essentially looking at y over x against x squared. So it's always vertical against horizontal. Okay, and then there is a line passes through 4, -2, maybe about here, and B12, 2, maybe about here. So if you're a person who requires diagrams, you may draw a diagram like that. Okay? Sorry, wrong. X is 12. And hang on, let me adjust this. A 4, -2, and then 12 is here 2. Sorry, should look like that. Okay? But anyway, we need to find an equation. So it's the same series of steps actually. We need to find out what is the gradient. We know what is our big Y and big X. Form the linear equation. Then we do some manipulation, although this one doesn't require logarithms, and get, okay, it reduced, right, to this form. Right? Could you give it a try? Okay, similar steps to what we saw in question 5. Give you about 3 minutes. Are you able to find gradient? What's the gradient? Half. Okay. So use the points. We get our 2 minus negative 2 over 12 minus 4. We get half. Okay. Our big Y is our small y over small x. Big X is small x squared. Okay. So big Y minus away. Just choose any one point. Okay. You can choose 4, 2 or 4, negative 2. Alright. So let's choose maybe 12, 2. Okay. So Y minus the Y coordinate of B. And then the gradient half x minus 12. Simplify. So big Y is equals to half x minus 6 plus 2 minus 4. Okay. Then we replace our big Y and big X. Alright. So big Y, we know that it is our small y over x equals to half x squared minus 4. Our aim is to have x cubed over here, okay, and then after that with all this over in this manner. Okay, so maybe we want to get rid of the denominator first. So that is done by y equals to x times half x squared minus 4. So we arrive at this. Okay, we want x cubed to be the subject. We now have our x cubed. So let's bring the 4x to the left. Okay, then we are left with our half there. Get rid of the denominator, we multiply by 2 throughout. Okay, so right. I arrived at this. It's the same thing. Okay, just changing it to the other way of writing only. Okay, and we get what we want to show. Alright? Okay, let's look at part 2. Okay, we want to find the values of small x when small y is equals to 0. So when small x is equals to 0, want to find small y, so we just do our usual, we want to find our small x when small y is equals to 0. So we simply do our substitution. So even if you can't get your answer in part I during the exam, question already give you the answer. So just continue doing part 2 and 3. Okay, so x cubed equals to 2 times 0 plus 4x. So we get x cubed equals to 8x. How do I solve after that? What is the next step? We have done this a few times. What should our next step be? Emily, what do you think? Do I divide by x throughout? Yes. Rina say no. Why cannot divide by x? Because there's equal over there, they cannot divide by x. No. Okay, we cannot divide by x because I said a few times already, x is a variable, right? You are not sure whether x can be a 0 or not. Okay, question did not say that x cannot be equals to 0. Right, so because it could be 0, so we cannot divide by x. Okay, because we cannot divide by 0. That is the reason. Alright, then how if I cannot divide by x? Alright, so what we need to do is to do factorization. Okay, so we need to be very careful whenever we divide things. We cannot divide unknowns, okay, variables. So I factorize out. Okay, and I notice that x will then be equals to 0 or x squared equals to 8. So x will then be equals to plus minus square root 8. Okay, and if you want to simplify that cert, we can, and that will be 2 square root 2. Okay, but I can simply tell you that x equals to 0 is not possible. Why would that be so? We got to reject x equals to 0. Okay, but why? Yes, Joseph.
Because the line never intersect.
Because the line never intersect, I can always draw longer. It's a continuous line. Okay? So, why can't x to be equals to 0? The reason is because, okay, take note, even if intersect, this is x squared, this is y over x. It's not your conventional small x and small y. So don't be confused by that. Okay? The reason why we have to reject x equals to 0 is because we are defining y over x over here. If my x were to be equals to 0, y over x can never be a number anymore. Do you understand? Okay, so that's why this one will no longer be defined. Okay, that's why we reject. Okay, so since y over x will not be defined. Okay, when we say something something cannot be defined, it simply means that it cannot happen, right?
So this kind of question will come out with
Maybe.
the Chpt.
It is not a trick question. Yeah, it is to test your true concepts. Okay. Right. Part 3. Okay. For part 3, there's an error in the question. Alright. It says that it gives you this point 19, point C. Okay. And it says that 19 is a point on the line. Okay, so on the line, this line has the equation big Y equals to half big X minus 4. If you think about it, if my X is equals to 1, okay, this is your big X, and this is your big Y, because we're referring to the line. Okay, this is where we need to be very careful already. Okay, because the points that we are given, it refers to the line, and the line is this equation. Okay, where we're talking about big Y and big X. Meaning to say, big Y is Y over X equals to half X squared minus 4. Okay, so don't blindly substitute. Don't think that small x is 1 and then small y is 9. Okay, so now that we have our 19, if big X is 1, right, if you go and calculate, big Y can never be 9. Do you realize that? Half times 1 minus 4 is negative 3.5. So this question got problem, okay? So let's just edit the question, okay, to let it make sense. It should be 3.5. So this one is a publisher's problem, okay, the textbook problem. In the exam, this kind of thing will not happen. Okay. So change it to 3.5, and then the question asks you to find the small x and small y values that correspond to point C. Okay, so earlier on I mentioned that big X and big Y refers to our 1 and 3.5. So that means that big X is small x squared and big Y is our y over x. So we can actually write it in this manner. Okay? So x squared equals to 1, we can solve that. We get x equals to positive 1 or negative 1. And then we can find out what is the corresponding small y. When x is equals to when x is equals to 1, okay, y over 1 equals to 3.5, our small y will be 3.5. So this is one case that could result in having this point. Another option is when small x is equals to negative 1. So small y is equals to negative 3.5. Wait, did I calculate correctly? Sorry. Half times x x is 1 minus, oh sorry, change wrong number. This one is negative 3.5, I bet. Then down here is negative 3.5, negative, 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 negative 3.5, so this one positive 3.5. Okay, so let's look at question 11. We got a diagram. Okay, this diagram, we achieve this line through having an equation y equals to pqx. So this is a non-linear equation. Okay, it got manipulated and arrived at this graph. Okay, where our big Y is ln y and our big X is small x. Question also said that the line has this point 0, 2 and the gradient is negative 3/2. In part I, they want you to find out value of small p and small q to 1 dp. Okay? I will just do it in the conventional way, okay, which I want to do such that it will help you in the next 9.2 chapter. Okay, usually in your 9.2 they will give you a non-linear equation and then you have to work out a linear one. Then you find the gradient and the y-intercept value. Okay, so what this means is that with our y equals to pq to the power of x, usually they will tell you what is the horizontal, what's the vertical axis label and the horizontal axis label. So we got to introduce our ln over here. Okay, so no choice, we have to introduce it. So let's just put it right at the start. Since our y is alone, we put ln both sides. So this is a skill that we have last year, not last year, during our home-based learning. Okay, so ln both sides, and ln bracket the whole thing pq to the power x. Remember that the x only belongs to q. Okay? Because that's a common mistake that you think the x belongs to everything of pq, then you happily bring down the x. That's not correct. Okay? So this one we make use of our logarithm laws. This is p times q to the power of x. So that means ln p plus ln q to the power of x. Only at this juncture, then you can bring down the x. Okay? So let me rearrange this into a linear form that fits our big Y and big X situation. I'm saying it as x ln q plus ln p. That means this is the big Y, this is my big X, this is my gradient, this is my intercept. Okay? Since question already gave you the gradient and the intercept, okay, question gave you gradient is negative 3/2. So ln q is negative 3/2. Then we can find q. And that would be about 0.22313. 1 dp is 0.2. Okay, then to find the value of q, to find the value of p, that is the y the question, our 0, 2 is actually the y-intercept, or rather the vertical intercept value, which is 2. So therefore, ln P equals to 2. And we get 7.4, 1 dp. Okay, then we want to find the equation relating x and y in part 2. Okay, so to find out what is this equation, alright, we want it to be in the form y equals to e to the power ax plus b. But right at the start, we are given y equals to pq to the power x. So actually what you're supposed to do is that we start off with y equals to pq to the power x. P we found it to be e squared, the exact value. Q is e to the power negative 3 over 2. Then it will be a matter of your indices laws. So same base e, power can combine. So we get 2 minus 3 over 2x. If you want to strictly follow the form, it will be negative 3 over 2x plus 2, okay, in the power form. Okay, I'll end off exercise 9.1 here. Alright, homework. I will write when here. Exercise 9.1, question 4D, 5B. Seven, 10, 14. Sorry, 10, wait now, 10, 12 and 14. Okay, are you asking me a question? Oh, okay. So, did 9, chord week, got a lot of tests. When's my next AMATS lesson? Just last Thursday. Can my deadline be on Thursday? Because my next time I see you is on Monday actually. But I know you got test. But you don't know A. So how? Very fun. Monday, Thursday, choose one. Thursday, okay. Right, next AMATS lesson, that means the Monday one, please bring your long straight ruler, okay, and graph paper. We will draw some graphs, right? That is the only graph that we have to, graph related question that we have to draw in AMATS. AMATS don't have so many graphs to draw. Right, thank you everyone. Thank you class. Don't want to quit. Thank you.